Today we will cover section 10.5, solve quadratic equations by completing the square. Example 1, complete the square. Find the value of c that makes the expression x squared plus 5x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So let's write that down. Example 1. Find the value of c that makes the expression, the algebraic expression, x squared plus 5x plus c a perfect square. So an expression that has a clear square root. Then write the expression as the square of a binomial. Binomial means two terms. Okay, so x squared plus 5x plus c, we have a variable squared term not being multiplied by a number, a variable term, and a constant. So to make this a perfect square, we take half of the coefficient of the variable term, half of 5, by doing 1/2 times 5, or 5 divided by 2. And that's going to give us 5 over 2. And then we square that, 5 over 2 squared. That's 5 over 2 times 5 over 2, which is 25 over 4. And then that is our value for c. And now let's substitute that in for c to get x squared plus 5x plus 25 over 4. And now let's factor it so that we can write the expression as the square of a binomial. So let's make two sets of parentheses. Put the variable at the beginning of each of the parentheses. And then it's going to be 5 over 2 at the end of each of the parentheses. So the reason why is anytime you have a variable squared term not being multiplied by a number, a variable term, and a constant the constant is the square of half of the coefficient of the variable term, you can factor it in this way, where you have the variable at the beginning of each of the parentheses and the square root of the constant, or half of the coefficient of the variable term, at the end of each of the parentheses. And then that equals x plus 5 over 2 in parentheses squared, since we have 2x plus 5 over 2's multiplied together. So now the expression has been written as the square of a binomial, the square of two terms. And we can check our answer by using FOIL, since we have two terms in parentheses times two terms in parentheses. So we're checking to see if it's been factored correctly. So x times x is x squared, multiplying the outer terms, x squared times 5 over 2 is 5 over 2x. And then inner is going to give us 5 over 2x. Then multiplying the last term in each of the parentheses, 5 over 2 times 5 over 2 is 25 over 4. And then adding the like terms, 5 over 2x plus 5 over 2x is 10 over 2x. Plus 25 over 4. 10 divided by 2 is 5, so that's x squared plus 5x plus 25 over 4, which is the same expression that we started with, so it was factored correctly. All right, now let's go to example 2. This is going to be really useful in solving quadratic equations, as you're about to see. Okay, example 2 is, turning the page, solve a quadratic equation. Solve x squared minus 16x equals negative 15 by completing the square. Let's write that down. Solve x squared minus 16x equals negative 15 by completing the square. Okay, so this is already set up perfectly to complete the square. Before completing the square, you have to make sure you have a variable square term with not being multiplied by a number, a variable term, and then equals a constant, a number not multiplied by a variable. So what we're going to do here is take half of the coefficient of the variable term, half of negative 16, which is negative 8. And then we are going to add negative 8 squared to both sides. So as long as you do the same thing to both sides of the equation, it remains true, balanced, and equal. And then we're going to factor the left side by, let's make 2 sets of parentheses. Let's put the variable at the beginning of each of the parentheses. So this is the same situation as example 1. We have a variable square term not being multiplied by a number, a variable term, and then a constant which is equal to the square of half of the coefficient of the variable term. So whenever you have a situation like that, the way you can factor it is put the variable at the beginning of each of the parentheses and then put the square root of the constant at the end of each of the parentheses. The square root of negative 8 squared is negative 8, since negative 8 multiplied by itself is negative 8 squared. Or put half of the coefficient of the variable term at the end of each of the parentheses. Same thing. So that's equal to negative 15 plus 64. Negative 8 times negative 8 is positive 64. And 2x minus 8 multiplied together is x minus 8 to the second power. Negative 15 plus 64 is 49. And of course, you can check to see if this was factored correctly by using FOIL to do x minus 8 times x minus 8 and combining the like terms, and you would see you would get x squared minus 16x plus 64, which is what negative 8 squared is equal to, of course. All right, so now that the square is isolated on one side of the equal sign, we can get rid of the square by taking the square root of each side. So the square root of x minus 8 squared is x minus 8. And then anytime you take the square root of both sides, you need to put plus or minus on the opposite side of the equal sign from the variable. Because really there's 2 answers anytime you take a square root. So it's going to be plus or minus 7 because not only does positive 7 multiplied by itself equals 49, but negative 7 multiplied by itself equals 49 because a negative times a negative is also positive. And then add 8 to both sides. So we get x equals 8 plus or minus 7. I just rearranged the terms to look a little bit better. So there are 2 answers, 8 plus 7, which is 15, and 8 minus 7, which is 1. So x equals 15 and 1. And the way you can check your answer is substitute in 15 for both x's in the original equation and see if it produces a true equation, which it would, and then doing the same thing for 1, which would also form a true equation. All right, so we could have also figured this out by moving everything over to one side and making it all equal to 0 by adding 15 to both sides and then factoring it. But so that might have been a little bit easier than completing the square, but completing the square is useful when the solutions are not whole numbers, but it was good to practice it first with whole number solutions, which is easier. Now we can get into more complicated completing the squares. Example 3, solve a quadratic equation in standard form. Let's write this out. Example 3. It says solve 2x squared plus 20x minus 8 equals 0 by completing the square. Solve 2x squared plus 20x minus 8 equals 0 by completing the square. So as I said at the beginning of example 2, in order to complete the square, you need to get the constant by itself on one side of the equal sign. So let's add 8 to both sides. So that's 2x squared plus 20x is equal to 8. And the variable squared term cannot be multiplied by a number. Therefore, we need to get rid of the 2. And to do that, we divide each side by 2. Which means each term gets divided by 2. 2x squared divided by 2, the 2's cancel out to get x squared. 20x divided by 2 is 10x. And then 8 divided by 2 is 4. Now we're ready to complete the square because we have a variable squared term not multiplied by a number, a variable term, and then equals a constant. So just like in example 2, we take half of the coefficient of the variable term, so half of positive 10, which is positive 5, and then we're going to add 5 squared to both sides. So that's going to be, I'm just going to make some more room here. I'll do a couple steps at once. So that's going to be x squared plus 10x plus 5 squared equals 4 plus 5 squared when adding 5 squared to both sides. And then let's factor the left side. Anytime you have a variable squared term not multiplied by a number, a variable term, and a constant is the square of half of the coefficient of the variable term. The way you factor that is you put the variable at the beginning of each of the parentheses and then put the square root of the constant at the end of each of the parentheses. The square root of positive 5 squared is 5 because 5 multiplied by itself is 5 squared. Or you can think of it as you put half of the coefficient of the variable term at the end of each of the parentheses when you have whenever you have a situation like this, because half of 10 is 5. And then we have 4 plus 25, and we have 2x plus 5's multiplied together, so that's x plus 5 to the second power equals 29. The square is isolated on one side of the equal sign, so to get rid of it, let's take the square root of each side. The square root of x plus 5 squared is x plus 5. Let's move up here. And then make sure you put plus or minus on the opposite side of the equal sign from the variable anytime you take the square root of both sides. Because remember, negative square root of 29 times negative square root of 29 is also positive 29. And then subtract 5 from each side. That's going to be x equals negative 5 plus or minus square root of 29. So you can leave the answer like that. That's fine. But that's really two answers. X equals -5 plus square root of 29 and x equals -5 minus square root of 29. And you can check your answer by substituting in both of those answers in for x in the original equation and seeing if you get a true equation, but that would be messy. Now let's do example 4, last example problem. It's a word problem. Solve a multi-step problem. You decide to use chalkboard paint to create a chalkboard on a door. You want the chalkboard to have a uniform border as shown. You have enough chalkboard paint to cover 6 square feet. Find the width of the border to the nearest inch. Let's write out the important information here. First I'm going to draw the diagram. We have a door. So here's the door. And then we have chalkboard paint in the middle of the door. With a uniform border going all the way around the chalkboard paint, meaning same width border all the way around the chalkboard paint. So here's the door, chalkboard paint, chalkboard paint. In fact, I'm going to shade this in. And then you have the border, the area in between the edge of the door and the chalkboard paint. So we need to find the width of the border. Represented by, the book uses X, let's use W for width. So that's W for this width of the border, W, W, W. So same width all the way around the chalkboard paint for the border. And the length of the door is 3 feet. 3 feet for the entire length of the door, 7 feet for the entire width of the door. And the chalkboard paint has an area of 6 square feet. Okay, so let's set up an equation involving W and the area of the chalkboard paint so that we can solve for W, the width of the border. So the area of the chalkboard paint is equal to the length of the chalkboard paint times the width of the chalkboard paint, because that's the formula for the area of a rectangle, and the chalkboard paint is a rectangle. So the area of that rectangular chalkboard paint is 6. The length of the chalkboard paint is 3 minus 2W, because the width of the entire door is 3 feet, but then subtracting the 2 W's, you're left with the width of the chalkboard paint. So that's, or I should say, the length of the chalkboard paint, I mean. And then the width of the chalkboard paint is 7 minus 2w. Because the width of the entire door is 7 feet, then subtracting the 2 w's, you're left with the width of the chalkboard paint, 7 minus 2w. Now let's multiply that out using FOIL, because we have 2 terms in parentheses times 2 terms in parentheses. First, outer, inner, last. Multiplying the first term in each of the parentheses, 3 times 7 is 21. Multiplying the outer terms, 3 times negative 2w is negative 6w. Inner, negative 2w times 7 is negative 14w. And then multiplying the last term in each of the parentheses, negative 2w times negative 2w is positive 4w to the second power. And let's set this up so that we can complete the square to solve for w. We need the constant isolated on one side of the equal sign. So let's subtract 21 from each side. That's going to be negative 15 equals, let's put the variable square term first, and then combine the like terms. Negative 6w minus 14w is negative 20w. And the variable square term cannot be multiplied by a number when completing the square. So let's divide each side by 4. So each term gets divided by 4. That's going to be negative 15 over 4 equals 4w squared divided by 4 is w squared. Negative 20w divided by 4 is negative 5w. Now we're ready to complete the square, because we have a variable squared term not multiplied by a number, a variable term, and then equals the constant on the other side, the number not multiplied by a variable. And to complete the square, you take half of the coefficient of the variable term, so half of negative 5, by either multiplying negative 5 by 1/2 or dividing negative 5 by 2. So 1/2 times negative 5 is negative 5 over 2. So that's w minus 5. Well, okay, we're running out of room here, unfortunately. All right, so we still need to square negative 5 over 2. So negative 5 over 2 squared, a negative times a negative is positive, then 5 squared is 25, 2 squared is 4. So we're going to add 25 over 4 to both sides. Um, 25 over 4 minus 15 over 4 is 10 over 4. And remember, anytime you have a variable square term not multiplied by a number, a variable term, and a constant is the square of half of the coefficient of the variable term, the way you factor it is put the variable at the beginning of each of the parentheses. And then put the square root of the constant at the end of each of the parentheses. But because the variable term is negative, let's put negative 5 over 2 at the end of each of the parentheses. You could also think of it as just putting half of the coefficient of the variable term, negative 5 over 2, at the end of each of the parentheses. So w minus 5 over 2 times w minus 5 over 2 is w minus 5 over 2 to the second power. And now, since the square has been isolated on one side of the equal sign, to get rid of it, we can do the opposite and take the square root of each side. Okay, so the square root of 10 over 4, 10 over 4 can be simplified to 5 over 2 by dividing both top and bottom by 2. And let's see, so now we have put plus or minus square root of 5 over 2. Always put plus or minus on the opposite side of the variable when taking the square root of both sides, for reasons that I've explained before in the previous example problems. And then the square root cancels out the square, so we get w minus 5 over 2. And then adding 5 over 2 to each side, we get w equals 5 over 2 plus or minus square root of 5 over 2. And then if you put that in a calculator, that's going to, let's put that in the calculator. Okay, so 5 divided by 2 is 2.5, 2.5, which is 2.5. And 2.5 plus the square root, hit the second button and the x squared button to get that square root symbol above the x squared button. And then 5 divided by 2, close parentheses for square root of 5 over 2. And that gives us 4.08 when you round it to the nearest hundredth, the second decimal place. Now let's do 5 over 2, or 2.5, minus square root of 5 over 2. And rounded to the nearest hundredth, or the second decimal place, you get 0.92 feet. So let's write that out. Approximately 4.08 feet and approximately 0.92 feet. Well, we can reject 4.08 feet. That does not make sense because it does not make sense for the width of the border to be longer than the width of the length of the door itself. The length of the door is 3 feet, so there's no way the width of the border, or the length of the border, however you want to think of it, is more than 3 feet. So it cannot be 4.08 feet. It must be 0.92 feet. And it wants the width of the border to the nearest inch. I forgot to include that. So 0.92 feet. Converting that to inches, you multiply by 12, since there's 12 inches in 1 foot. Or think of it this way, replace feet with 12 inches. Since a foot is 12 inches, 0.92 times 12, if you work that out, that's 11.04 inches. Rounded to the nearest inch, it's 11 inches. So the width of the border around the chalkboard paint needs to be about 11 inches. And that concludes section 10.5, completing the square, or solving quadratic equations by completing the square. Thank you.